This is TinyFlex HD 75mm pusher whoop, fits in your pocket, shoots 4K 60 FPS, weighs less than 50 grams without a battery, which is about 1/3 of a GoPro. A GoPro that also flies and is considerably more fun at parties. The frame is rubber entirely. And before you close the tab, I'm going to prove that's actually a good thing.
In this video, how I shaved 20% of the weight of an already light drone, how I proved with real test equipment, a full step-by-step build guide, and a maiden flight, including an unexpected lesson about DJI O4 Lite stabilization.
How did I get here? If you haven't seen Luffy video, go watch first, I wait. For those who did, you already know the origin story. I designed the 85mm rubber whoop frame from scratch, iterated until it flew properly, then crushed it into everything I could find until it stopped surprising me. It survived every time. The concept worked better than I expected, and that pushed me to do something dangerous, spend even more time on it. So I made it smaller. 85mm was great indoor, but in tight spaces it was always slightly too big. The kind of drone that fits through a doorway fine but makes you think about it first. I wanted something that generally disappears into spaces, that you can throw through a gap on instinct and deal with the consequences later. I also wanted it lighter, so I shaved the material from the guards, refined the frame geometry and cut everything that wasn't doing structural work. And while I was in there, I fixed every small design quirk that had been quietly annoying me in my sleep. Nothing dramatic, the kind of detail only the person who designed it would notice, but they add up. The result: 75mm motors diagonal, 40mm props, DJI O4 Lite air unit. Same concept, sharper execution, smaller everything. 4K digital camera system instead of the ancient analog one. And eventually it ended up to save more than 10 grams in the process. And at this point, after all the iterations, all the crashes, all the 2 AM betaflight sessions, this is generally my favorite drone I own, which is either a great endorsement or a concerning sign about how I spend my time. Probably both. So how do you make something lighter without making it weaker? You think carefully, and then you think again, and then you remove some material and hope for the best. In this case, it actually worked. The first move was shrinking the guards and the arm's length. Smaller drone, lower impact, less protection needed, which means less material, which means lower weight, which means lower inertia, which means you need even less protection, which means you can remove even more material. It's a recursive loop. Every gram you save lets you save another gram. You just ride it until you hit the point where removing anything else will be generally stupid. That's your optimum. Along the way, I also removed the fin. I wanted to move the battery on top, which freed up space, cleaned up the geometry and saved more weight. No external receiver either, that's gone. And since the drone is lighter, the arms can afford to be slightly less rigid, which saves weight again. Going digital costs me something. The O4 Lite system is heavier than an analog camera and the VTX. That's the tax you pay for the 4K 60 FPS. But even after paying it, the TinyFlex HD comes in 10 grams lighter than the Luffy. On a drone that was already light, that's a 20% reduction. That's not a small number. Now, about those arms. Single parts are soft, very soft. You can bend them with 2 fingers. They flex like rubber because they are rubber. If you handed one to someone without context, they'd assume it was spare gasket for something. But here's what happens when you put the 2 halves together. The assembled geometry creates an Octet truss structure. If you've ever heard of it, it's one of the best ways to rigidity ratio found in nature and engineering. The reason it works is elegant. It converts bending loads into compression and tension along the struts. Bending is the enemy of the stiffness. Compression and tension material handle those extremely well, even soft ones. Think of a rubber eraser. Grab it and bend it sideways, it flexes easily. Now try to compress it along its length. Suddenly it resists, same material, completely different load path. That's exactly what the Octet struct does for the TinyFlex HD arms. But I'm an engineer, feelings aren't data, so we tested it. I designed a 4-point fixture that locks the drone at the motor position and mounted it in a universal test machine. The test is simple. Apply 2 Newton of force to the center screw mount and measure the displacement. Same for the 2 drone. Less displacement equals more rigidity. More rigidity equals better vibration handling and the cleaner flight performance. The competitor I tested against is the Mobula 7, one of those popular commercial whoop at this size. Mobula 7 displacement
0.94 mm.
TinyFlex HD displacement
It's 0.26 mm minus the initial offset, it makes it at 0.2 mm.
From 2 pieces of printed rubber, we just cleared it by a significant margin. I expected good flight performance. The data agrees. Before you hit the print, 2 things worth getting right. The guards go on the build plate with the motor mount facing down. Yes, this generates a lot of supports. The motor mounts are the most mechanically critical parts of the frame. The battery holder gets laid on its side. This is the only part printed in 95A TPU. Top frame 3.41 grams. With the guards 10.15 grams. And with the camera mount 11.08 grams. I know I forgot the battery holder. That's another 1.34 grams. Let's beat it together. I keep this focused on design specific advice, otherwise this video is 2 hours long. Motors are Newbie Drone Flow 1102. They were perfect the last time, so I ordered another set. No need to overthink it. Motor connectors, remove them. Save the weight you're soldering directly. Wire stripping. My tool didn't have small enough holes for the motor wires. Fortunately, silicone insulation is soft enough to strip with your fingers. Highly precise, calibrated fingers. This is a legitimate technique and I'm sticking to that. The screws are 1.7 by 20 millimeters. These are not optional details, they are essentially what holds the entire drone together. The long structural screws go in first. Now, against every general mechanical design principle I've ever been taught, I designed the holes to grip the screws directly, no nuts. The reason is purely practical. The top frame holds the screws in place during assembly, so you have 2 free hands for everything else. Sometimes convenience beats convention. Slide the battery holder in next. Mind the orientation. There's only one way it works correctly. 2 rubber standoffs go on the side not covered by the battery holder. This gives you a flat, even surface for the boards. Small detail makes a real difference. Before installing the O4 Lite, a durability step I strongly recommend. Reinforce the weak connections with the UV glue, the camera connector base, and especially the antenna connector, which is famous in the community for popping out at the worst possible moment. Do the same on the camera side. UV glue is ideal here because it cures in seconds and stays flexible. Install the soft mount spacers on the corners of the O4 Lite board. These come in the DJI box. You don't need to source them separately. DJI actually thought of something, note it. Slide the O4 unit board in gently until it sits fully. Follow my orientation. It minimizes excess cable on both the camera and the antenna wires. Before you close everything up, check the fin orientation on the camera mount. It needs to align with the camera cable. That fin is there to protect the cable in a crash. Pop the clips in. Align the holes. And insert the self-tapping screws. And here is my first mistake. I assumed the O4 Lite could rotate the video feed in the goggle settings. Reasonable assumption, wrong assumption. It cannot. The fix was easy, just rotate the camera so the wire points up instead of down. Protection still works, the angle is still adjustable, and we never speak of these again. The antenna was over-engineered. I cut it. The release version of the frame will have this fixed in the design. Side effect, minus 0.23 grams. The top assembly also looks noticeably cleaner without it. Accidental improvement. The flight controller came pre-soldered, so installation is just popping in the red rubber dampener from FlyWoo, which also comes in the box. Twist the VDX cable before routing it. Motors, you can solder them now or after full assembly. Easier soldering before, easier motor installation after. Pick your poison. I soldered first because I'm not a confident solderer and I prefer doing the difficult thing with maximum access and minimum stress. Place the red flight controller under the O4 board. Connect them together. Place the second half of the frame on top. Route all 4 motor cables to the bottom side. All 4. Tuck them flat. Twist slightly if it helps with routing. Now tighten the long stuck screws. Stop when the tip of the screw is just barely visible on the opposite side. That's your reference. Don't go further. You're threading into TPU and it will tell you when you've gone too far. Last screws, the motor mount screws. I found large head screws at the right diameter and length, and I strongly recommend them for anyone using the same 3-hole M1.4 motor mount pattern. The larger head gives you confidence that the screw won't pull through the soft TPU under load. Small detail. Real peace of mind. Link in the description. And this is one of my favorite upgrades in the HD version. The motor mounts now do double duty. Secure the motor and they lock the 2 frame halves together, which means the separate side lock screws from the Luffy are completely gone. Optional but recommended. Add a small piece of foam at the bottom. Zip tie the battery lead in the position you see here. This keeps the cable at minimum length, which matters because it's one of the heavier cable on the build and lets you install the battery from either the left or the right side. The right side looks slightly less elegant. We accept this and move on. Final scale check, just under 50 grams. As promised, I'll take it. So the drone is complete, sitting on the bench looking suspiciously good for something I printed myself. I had no real doubt it would fly well. The universal test machine results were clear and the Luffy had already proven the concept at larger scale. The only open question was how well. Turns out visually extremely well. Line of sight, it moves like silk, smooth, precise, following lines with exactly the kind of authority you want from a well-tuned frame. First impression, very good. The first FPV session was at the canteen. The drone flew well, but I immediately ran into a personal problem. The latest betaflight version has a yaw response that is significantly faster than what I was used to. My muscle memory was confidently wrong. A couple of crashes followed. The drone was fine, my dignity less so. Then came the footage retrieval. Simple task. Should take 2 minutes. It did not take 2 minutes. My first assumption was that I could pull the video wirelessly via the DJI phone app. A reasonable assumption. Wrong assumption. The O4 Lite doesn't have that function. Fine, a cable it is. Except the O4 Lite connector was pointing directly towards the motor. The cable physically couldn't reach. The correct solution is to order a 90 degrees USB cable online. I was impatient, so instead of ordering the cable, I took a normal cable and started carefully removing the plastic housing until I exposed the internal wires. Then I warmed up the hot glue holding them, bent the whole thing 90 degrees and made my own adapter. I do not recommend this process. Not all the cables have a data connection. Some have connector PCBs that are too long to bend. Some have internal wires that are too fragile to survive the heat. It is essentially a lottery. I got lucky. The videos came out and they looked like this. Like an earthquake. A significant one. The kind where people run outside. So tuning time. I tried the 48 kHz motor timing, then 96 kHz. Both made a noticeable difference, just not a good one. I tried carefully PID tuning, working from assumptions about motor size and likely vibration frequencies at this scale. Still pudding. I looked into RPM filtering, enabled it, watched the CPU on this flight controller jump to 60% and immediately turned it back off. At that point I shifted to hardware solution. Before touching the soft mounting, I wanted to try some different props, which is when I discovered I had almost no 40mm blades at home.
Wrong hole sizes, incomplete sets, props with damage from previous crashes. The kind of parts drawer situation where everything is technically present but nothing is actually usable. But at the bottom of the drawer, one set of Genfan tri-blade props. Installed them. The video stopped shaking. Not perfect. There are occasional random jitters still visible, but smooth enough to be generally usable footage. One prop swap solved what an hour of software tuning couldn't. I have more props arriving to test. I'll give you a quick update on the final results once I've run through them. So if you're building this, check the description or the comments for the latest recommendation before you order.
But for today's video, we stop here. The bill of material and the STL download link are in the description, free for now. I'm generally not sure for how long, so if you want to build one, don't overthink it. This also probably marks the end of the Indestructible Whoop series, which gave me a lot of satisfaction, more than I expected when I started it. I should be honest though, it is not 100% indestructible. That would be a bold claim for anything made of atoms. But it's resistant enough that I fly it without the background anxiety you get with an expensive carbon frame. And when it hits something and falls to the floor, which it will, I pick it up without holding my breath. I dare to claim that this is the best 3D printable Whoop frame you can find at the moment and a serious alternative to the commercial ones. What comes next? I'm not entirely sure yet. There are other things I want to build and test, and this channel tends to follow wherever curiosity points. If that sounds interesting to you, stick around. Thanks for watching all the way to the end, generally appreciated. Arrivederci alla prossima!